So the next part is the neuron classification, and for this we've used one of the many ways, one of the many algorithms related to machine learning, and this is something we have a lot of experience here at DR Vision, not only with the patents, but there's a lot of other work that we've done over the decades in this area, and we have a lot of products deployed that have some sort of machine learning in it, either guided or not guided. We have some pixel classifiers and a few other things, but for today and for this application, what we've developed here is a neuron classifier. So to get to the next step, what we've used is a particular type of an ensemble machine learning method for classification. We picked one that is very robust and high performance, means it has low error and runs very quickly. Because there is a need, of course, for analyzed data sets, we went to a very well established reference, the repository of reconstructions. It's the neuromorpho.org webpage, which holds thousands of neuron reconstructions. And we used a sample of those reconstructions to train 3 classifiers, one for human, one for rat, and one for mouse. All of those classifiers that we've created using the neuromorpho data are fully open and free. They will be available on our website to download for everybody. And on the software, so in Aivia, you'll be able to not only apply a classifier that already exists, like the 3 that we've created, but you'll be able to augment the ones we have created. So you can take, for example, imagine you're working with mouse neurons. You can take the mouse neuron classifier that we've created using the neuromorpho data pool. You can augment it with additional examples from your research, and then you can apply that classifier on other data sets. And we'll give you a measure of accuracy per class and also for the whole classifier. For the classifiers that we have built, the 3 that we have built, we made sure that we're not overfitting, and we did quite a bit of testing to make sure that that's not happening. And one of the methods we used was k-fold cross-validation. You probably need to do something similar. If you need any help with this kind of validation, we can help you as well. If you're using Aivia and you create your own classifiers, you need some help to make sure they are good, we can help with that. As a rule of thumb, we always used 9 or more cell examples, and it's really better to have around 50. From around 50 cell examples, the classifiers tend to be really robust. And typically it's not necessary to go as high as 100 cells. So it's pretty small number considering the results that you can get. It's a very small number of cells that you need to use. So the workflow, how it works is, you can, first of all, you have to detect the neurons, and you can use Aivia to do that, or you can use other tools. There are quite a few other very good tools out there. So once you have the detection done in Aivia or in a different tool, you can, if it's in Aivia, of course, you already have the reconstruction in the software. Then what you do is you go to the part of the software where you do the classification, and you can basically assign, by clicking on the cells, assign each cell to a particular type. You do that for a few examples, and once you're done with this, you hit the button that teaches. And at that moment, the classification or the classifier is built, and it will also give you a measure of accuracy, the likely accuracy for each class, and also for the whole classifier. You can save that off to use later, or to send to a colleague, for example, or to augment later if you want to add more examples, because you may be working over many days. So you may add some examples today, some more examples tomorrow, and you can continually add and basically make the classifier even more accurate. Once you have a classifier, either one of the ones we are shipping or the ones you create afresh, you can then apply that classifier to a new data set that has reconstructions, and you may want to know how many cells in that data set are of a particular type. And that creates, once you apply, it creates subgroups for each type of cell. So the classifiers that we've created, I mentioned we made one for human, one for rat, and one for mouse. There should be some text here saying mouse and rat and human, but this is what we have. So the human one has 4 cell types, and I have a little bit more detail in the next slide. We used a total of 101 cells, and we reached the overall accuracy of 95%. That's what you can expect when you run this, is that 95% of the time you're going to get those 4 cell types correctly assigned. For the mouse, we have 6 cell types. We use 287 cells to teach, and we can reach 98% accuracy. And for the rat, 6 cell types as well, and 354 cells were used to do that, and 93% accuracy. So this is a little bit more detail, and you can see here which cell types we have taught on, and they are slightly different because the data pool is still not very complete, especially for human. There's only 4. We only have 4 types, and even for a few of those types, so for stellate and granule type neurons, there are only 5 examples available. So we've used all 5, and with the stellate also there's 7 examples, so we used all 7. But overall, very few examples of neurons for human. Not so for rats and mice. So we have a lot more cells in each of the classifiers, which should mean they are more robust than the human one. But still, we felt that the human one is going to be robust enough to be usable. So what kind of applications can you do with this classifier? The obvious one, or the one that we talked about so far, is just classifying different neurons. You have a sample with many neurons in it. They may be different types, and you can apply this classifier so that it tells you which types you have and how many cells you have of each type. You may also have a different study where you have just one type of neuron, but there are subclasses of that neuron. Maybe there's something different about them. So you can teach based on your experience to create subclasses. You may also have a different phenotype due to an intervention that was done, a treatment, for example, or some sort of intervention that you've added to that animal, and then it may change something on the phenotype of the cell type that you're looking at. Or it may be to do with developmental stages. So maybe you have developmental stages and you want to see how the neurons evolve over time for a particular type. So that's just some examples of what you could do. Of course, you can also look at disease versus non-disease states. That's also a likely application. So in that case, you would take the non-disease state, teach based on those examples, teach based on the disease state neurons, and then you could present the software with a sample that you don't know if it comes from a patient or from somebody healthy. You can apply it, and it will tell you already if there are already any cells in there that are likely to be from a patient. That might be an indication of a disease that is at early stage, for example, and that you would otherwise not spot. We can import a standard file already, which is a SWC. This is the most commonly seen neuron reconstruction file. And very soon we'll be also able to load IV and VRML files. So this will cover pretty much 100% of the reconstructions that exist out there. But SWC is a great way to start too. So this is how it looks when the classifier is open in Aivia. You have this panel here that shows all the neurons that are available for classification. And below here are all the classes that are already loaded. And down below you will see there's these multiple tabs, and each tab indicates a class. So in this case I have already applied a classifier. I've applied a classifier, one of the ones we pre-taught. And once I apply a classifier, I get all of these tabs down here, and the cells can also be color-coded based on the class that they belong to. So I think now I'll go into Aivia to show you how to do this very briefly. We have here, I've loaded a data set with multiple neurons. You can see it here, it has really a big mixture of neurons of different types. And I don't need this panel anymore, so I can close it so we have more space for visualizing the neurons. And they are mixed. I haven't applied yet the classifier to this, so that's the typical situation. You'd have lots of neurons in one cell, in one sample. So to start the classifier, there is a tab or a button on the top here that will open it, and it will show me all of the neurons that are in this data set. So you can see them. These are just thumbnails that indicate there is a neuron there. There's 10 of them, and they have not been assigned right now yet. So I could create a new, at this stage I can either create a new classifier or I can apply an existing classifier. And as I mentioned, we offer you 3 classifiers out of the box, and they are here. You can select through them, and I could, if I wanted to, augment one of these, or I can just create a new one. So to augment one, I would pick the one I'm interested in. I would then click on a cell like this one and drop it into the appropriate group. I can also select it from the view, so I can select this cell, and it should show me which cell it is from the top. So it's neuron 7. The one I just selected here is neuron 7, and I can now drop neuron 7 into the appropriate group. That's something I can do. Or from the thumbnails that are being generated, I can also see what type it is. If I'm an expert in this field, I can see what type it is, and I can just pick it up and drop it into the right class. That's how you would create a classifier. Once you have all the cells in the correct classes, you then hit the button down here that says teach. That's how we'd create one. And if we have a bit of time, I'll probably still do that. But now I wanted to show you how to how to apply an existing classifier. So we have these 3. I've picked the one for mouse neuron classifier, and I will apply it. And what you will see, and I'll open it so you see it. So right now there are no objects down here, no tabs. That means there are no subgroups created yet. But once I hit this button, the classifier that we have pre-taught will be applied on these images that are here on these neurons, and as a result there will be multiple tabs down here. This is in the spreadsheet zone. So if I apply it, you can now see there all of these are visible, and I just need to make sure these are on so that the measurements are on, and those are being calculated. So there we go. So we have here the measurements for each of the dendrites for each of the classes. So if I go into each of these, I should have measurements. Okay, so here, for example, the motor neuron type or the granule type, that looks like there's only one granule. There are 1, 2, 3, 4, 5 motor neurons. So it has already done that classification for me, and I can color the dendrites by class. And you can see now, if I zoom out, seems like a lot of them are of the same type. There's 2 types there, or 3 types, and there's one more on the bottom, so that's another type. That's for sure Purkinje cell. Yeah, that's one, which is the one here. So that's how you would apply a classifier. You can then, of course, explore the data even further by exporting it to Excel, and you can look at the parameters for all of the objects that are of a particular class. And in this demonstration, the classes are just types of neurons, but classes could be anything, as I mentioned in my in the slide that I was showing you earlier. In here, you could use as inspiration. These are some ideas for applications, but you could do many other applications. In the near future, probably in a couple of weeks or 2 or 3 weeks, we will do another presentation where we will be focusing on how we are doing the machine learning, or what kind of machine learning algorithm we've used, how it differs from others, and the benefits of using it. But you're very welcome to start testing the classifiers that we've created.